this one and maybe do some data tabulations. Okay, so data tabulations, as you know, works very well with qualitative data. So let's import some qualitative data. So we have that, and of course, you want to do some. You can also do some descriptive statistics here, but you know, descriptive statistics is not good for qualitative data unless it has been well quantified. So for this one, let's tabulation method frequency. So you can you can tabulate that, which is similar to what we were doing in that other tool. Okay. So you can do all these tabulations. You can tabulate. This is just for tabulation. Then of course you can do other things. You can include other tabulation methods. Let me try that one. Or maybe missing value count. Or maybe let's say mean calculation. Let's try for this one. Okay. Cross tabulations, maybe with that one. So you can see the cross tabulation there. You see a cross tabulation right there. You can copy the table, paste it in your Microsoft Word Office. Yeah, you can do quite a lot of different tabulations. So cross tabulation, you can also do it in SPSS. But there's just a lot of navigation in there that you may want to do when you are doing that. Okay, so I think this basically that's what you can do. But if you are going to replace this with some quantitative data, because qualitative data doesn't work well with descriptive statistics, okay, but mostly descriptive statistics, we like doing it using quantitative data. So you can see just on a click of a button you're able to show descriptive statistics for qualitative data. So for this one, this particular data tabulation tool comes with a descriptive statistics function for qualitative data. Okay, so just by a click of a button you are able to get all these outputs, and they bring you options to copy them as tables. So you can basically select all the data set if you want. So I've selected all the data sets and it has generated all these tables just by a click of a button. Okay, so now let's move on to something else. Let's go to I think I would like to do the individual one first, which is OLS time series regression. Okay, so these are things that we already know in Stata and SPSS. Okay, and eViews as well. So OLS time series regression, let's go and so let's select a quantitative data set that is time series. Let's go for this. Oh, sorry, I think that's qualitative. Let's click that one. Yeah. Okay, so now we have that data set inside, and we need to just pick our time variable, and our time variable is year, and then the time range is from 1990 to 2023. Then we want to choose which one. Sometimes in research the augmented Dick-Fuller test might be criticized if you only use it as the only determinant of stationarity. So you may want to use more than one stationarity test just to confirm the results. So we have augmented Dick-Fuller test and we have the Phillips-Perron test for stationarity. So you can, let's go for augmented, and then stationarity test options. Okay, so we'll pick our, okay, let's just pick all the variables, like all of them first, or maybe let's just pick the ones that, anyway, let's just pick all of them. So we have all the variables selected, and then okay, so we want to specify whether they should be a constant or they should be no constant. Let's just do what we always do. Let's add a constant. Then let's add one lag there so that it's really augmented Dick-Fuller. And then let's run the stationarity test of the variables at level. So there we are. So we have done the stationarity test of the variables at level. And you can see that GDP growth is stationary, and external debt stocks is not stationary, and GNI is not stationary. Official exchange rate is also not stationary, and inflation is stationary. So another distinction between Stevanialysis and other statistical software is that Stevanialysis, unlike Stata and eViews and SPSS, is that it also indicates or provides a simple interpretation of the data. Like, for example, as you can see, it has shown us which variables are stationary and which ones are not stationary, besides just looking at the p-values. Okay, so we can see that this one is stationary at 5% level of significance, because of course the p-value is below 5%, because we can see that 0.015, and we also have this one, which is also stationary. As you can see, this is below 5%. So yeah, then we can also run these variables at the first difference. Oh, this is a regression, sorry. We can run these variables at first difference as well, to check for stationarity, given that we basically run the stationarity test based on variables that have been differenced. So what this does, when you click this button, it automatically differences the variables and then runs a stationarity test based on the stationarity options that you have selected. So here we go. So we run that, and you see that after we difference the variables at first difference, GDP becomes stationary, okay, at first difference. External debt stock remains non-stationary. GNI becomes stationary, and official exchange rate becomes stationary. Real effective exchange rate also becomes stationary, and inflation also becomes stationary. Okay, let's try to change the test to the Phillips-Perron and see if we may get the similar results. So you'll notice that these results seem a little bit similar. Or maybe let's I don't want to restart the program. Anyway, let me just use the augmented itself. Okay, let's use that. Okay, so now if we want to run a regression, we can run the regression. We have done all that. Then we can run the regression based on variables at level, or we can run the regression based on variables at first difference. So for now, let's see what we have. So the data is obviously not perfect, so let's see. So we have let's pick dependent variable as GDP growth, and let's pick external debt as the independent variable, official exchange rate, and inflation as independent variables. And then we run the regression at level. So when we run the regression at level, you'll notice that the output has been generated, and what you can see is that GDP is our dependent variable, and these are the independent variables, and the number of observations are 33. R squared is 0.40, so meaning we're explaining 40% of variations in GDP growth, leaving about 60 something percent of variations unexplained by the model. So we also have the F statistics, which shows the p-value there as well. It's statistically significant, meaning that the variables that we have included in the model seem to have some explanatory power. So on the dependent variable. Then, of course, we can see that the table has been generated. We have the coefficients, we have the standard errors, we have the t values, we have the p values. We also have the p values in decimal form rather than the standard form here. Then we also have confidence intervals. We have the level of significance interpreted there, of course. Then we also have significance markers right there. We also have the ANOVA table there. So yeah, this is just a simple OLS regression output. And if we want to go further, we can generate diagnostic tests for this OLS regression. So when we click that, it automatically generates all of them and provides some assumptions that are associated with the OLS regression. So you notice that, of course, it brings this output which simplifies the outcomes of the results, and it also provides some interpretation. No evidence of autocorrelation, no residue autocorrelation, no conditional heteroscedasticity, residues not normally distributed. So those are the properties associated with the model that we have run. So so here it's saying that errors are not normally distributed. Yeah. Then of course, as you can see, you can also go further by generating residue distribution graphs. Okay, so but the other thing we may want to check is maybe the time series aspect, because we want to see exactly how the variables are moving, because sometimes figures may be deceiving. So when we look at the visual representation, sometimes it helps us to see whether really they are tarrying with the figures. Okay, so we generate that. These are combined level charts. Okay, so we have the combined with what? Combined with each of the variables in the graph. So these ones, this graph shows us the variables at level. Okay, so you can see that variables at level, there are a few variables like GDP, which was stationary at level, and we also have which one is green, official exchange rate, which was stationary at level because they were revolving around the zero bound. Okay, so then we can see that external debt stocks was not stationary because it's even above the zero bound, and just over time goes to the zero bound. And then we also have inflation, which in the first periods is not stationary, but over time becomes stationary. But basically overall, it is very difficult to see that it's stationary. So if we difference the variables and then we generate the graph at first difference, we can easily see that. So there we are, and we have generated a graph that shows us the way the variables are flowing when differenced. So you can see that when we difference the variables and we generate the graph based on different variables, all the variables start revolving around the zero bound. Okay, so this shows that at least visually all the variables somehow become stationary at first difference in this graph. But when we look at the figures, where are the figures? When we look at the figures, okay, when we look at the figures, even though visually we can see that the variables seem to be all stationary somehow, but there is this problematic variable which sometimes goes out of the zero bound and then goes way below the zero bound. Not very stable variable, I think, and that variable could be, let me see, that variable could be this one, okay, external debt stocks, okay, and external debt stock. So external debt stock, yeah, it is the one, probably. No, this looks like it's inflation. Okay, yeah, it's actually inflation. Not very stable, but it does become stable over time. Then for external debt stock, okay, let's see, okay, it's there, but not very stable, as you can see, because the only thing is that for inflation, we can see that the only periods that doesn't look stable is this period, the period from here to there, here, and the period from here to there. Okay, but for external debt stock, what we can see is that here it wasn't that stable, here it wasn't also 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 that stable, here that's why we see that even in the figures, external debt stock is considered not stationary even after the first difference. Okay, so that's how you can run a simple OLS regression. And of course, if you run these results even in let me show you that what you get in Stevanialysis is closer to what you get in Stata. So let me open Stata. Okay, when I open Stata, I want to open the data browser, and then I will open, let me see. Okay, let me go for data set and then quantitative. Okay, so what I'll do is that I'll import the Excel data, the same Excel data into Stata, so that we can make a comparison. I'm not sure where the problem. Treat first row as data. No, treat first row as yes. Okay, so now we are in Stata, and I want to import the same data set into Stata and then just run a simple regression based on the variables that we ran in Stevanialysis. Okay, so we open the data browser, we paste, and we treat the first row as the variable names. Then we have that. Then here we are just going to do a bit of some changes, like we just change the variable names here so that they can easily be recognized. So this is GDP growth. Okay, then oh no, let's say this is GDP growth. Okay, and then we say this is external debt, and then so I only pick variables that we included. This is official exchange rate, exchange rate. Okay, then we have inflation. Okay, so we have just shortened the names for the variables, and then we can run. First and foremost, we say tset yay, so that we have the period from 1990 to 2023, just like we have in Stevanialysis. Remember that we picked from 1990 to 2023. So yeah. So then we'll run. We say regress. GDP is the dependent variable. We have external date. We also have official exchange rate, and we have inflation. So then we run the regression. Okay. So when we run the regression, we have GDP growth, we have external debt, official exchange rate, okay, and inflation. So let's see what we have. Okay, let's see what we have here. So in Stevanialysis, the intercept is 8.9804. In Stata, you can see that the constant, which is the intercept, is 8.9803. So just a small difference there, of course. And then for inflation in Stata is 0.0046. In Stevanialysis, the coefficient for inflation is 0.0046, which is okay. So you see, the only difference in Stevanialysis and in Stata is the rounding off of figures. So you can see that for the coefficients, Stata has 1, 2, 3, 4, 5, 6, 7, about 7 decimal places. So then in Stevanialysis, we're only keeping it to 4. So then I think for the standard errors as well, you can see that in Stata it's 1.3795. In Stevanialysis it's 1.3796. So now let's go to the p-values. You can see that for external debt, the p-value is in Stata it is statistically significant at 5%. In Stevanialysis it is also statistically significant at 5%, or even 1%, if you can say, if you want to say that. So then okay, official exchange rate is not significant in Stevanialysis. Official exchange rate is also not significant in Stata, and the p-value is 0.373, whereas in Stevanialysis it is 3726. Okay, and if you round it off, that will be 0.373, which equates to what is in Stata. Okay, then for inflation is also not significant in Stevanialysis, and you will see that in Stevanialysis the p-value is 0.8, whereas in Stevanialysis the p-value is 0.79. Okay, and if you round that off, you get 0.8, which equates to what is in Stata. Okay, so yeah, so you see that basically what you are getting in Stevanialysis will correlate with what you get in Stata, except that in Stevanialysis the results seem to be in Stevanialysis it provides a user-friendly framework of doing things than in Stata, where you have to type in commands, and if you don't remember the commands, then it will be difficult for you to run the stuff. Okay, so let me move on to other things in Stevanialysis. I was going to run through the OLS cross-section regression, but I think these are just the same things. Won't have much of a difference. Let's try to now focus on things that makes Stevanialysis different.